Okay. All right. Lesson number 9, constructors and return methods. I think I'm done. I'm going to take this one down today. Dark theme with Sublime Text. If you haven't changed it, I can keep the link up on my YouTube, but I'm just going to take it down from this section. So if you want it, especially now that you're going to be working from home for a couple weeks, you might want access to this. If you do, just email me, let me know, and I can provide it to you. But I'm probably going to take that down. From here, we're going to go on to lesson 9. Lesson 9 is about constructors' return methods. And at the very end, there's a pretty good review of the different methods that we've discussed as we go through. Okay, so object instantiation, we've done this before. New scanner, system.in is how we would bring in a scanner, an object from the scanner class. Okay, we've done this lots of times. We're going to need it for this one, so I just thought I'd review it real quick. Scanner keyboard equals new scanner. Remember, this is the class we're creating an object from. The object name is keyboard. So now the object keyboard is going to have the same characteristics and behavior as the class scanner. And then we say it equals new scanner, system.in as an input device. Okay? Constructors are very similar to methods. They have the same name as the class. They have no return type, no void, no ints, nothing like that. They initialize all instance variables. Okay? So constructors can be a little bit confusing. They seem to really not have any point, but they need to be there in order to initialize and set up those instance variables as we go through. So here's an example of a default constructor. So we have our class called triangle. We have our instance variables, int side A, side B, side C, and then we have our constructor method right here. Okay, so all it is a public triangle. Nothing's being returned. Nothing's being output. Nothing is happening. We include side A equals 0, side B equals 0, side C equals 0 to initialize those instance variables. Okay. Initialization of the constructor. So we have public triangle, and we include the parameters of the three variables that we're going to be using. And then we say side A equals A, side B equals B, side C equals C. So when these parameters get passed in, they attach to the correct instance variable. Okay, and I have an example of this inside. Okay, so we have this set up right here. We have our instance variable set up right here. Our class name is here. Our curly brace for the class is there, and you can see the closing brace is there. And then we have our constructor set up here to initialize the sides at 0. And then from here, we have side A, int A, int B, int C. And then we set sides to 5, 6, and 7. So then when we output this using this class, that's the values that those three instance variables hold. Okay, and then here is our modifier method where we set the value of the sides. We create these three variables that are only present within this method, and we say anything that gets passed into this method is going to equal side A, B, and C, and then there's our print method right there. Okay, I think I've gone over that enough. I don't necessarily have to go over it again. If you're still stuck on that or don't understand, I'll go through it. Okay, just come see me after and I can go through it and make sure that you understand. Now, variable scope. Any variable defined inside the braces only exists inside those braces. So if we look at instance variables, okay, we create those instance variables inside the main class braces, curly braces. Okay, now they can exist anywhere within those braces. So anywhere within these two, they can be used. These instance variables are only being created inside these braces, therefore they can only be used within this method. Okay, and there's a better example further down as we get to this spot right here. Okay, and I have this in an actual class, so it's a little bit easier to see. Okay, so I have lesson 9A, that's the name of my class. Here's my opening and closing brace. And then I have a instance variable right here, private int fun. It is inside the root braces. It's inside the class braces. Therefore, this instance variable can be used at any point within this class. Okay, and if you go back to this, you'll see methods change contains a local variable named fun. Local variables take precedence over instance variables. Local variables can only be used inside the method which they're defined. Okay, whoops. So now this is where it can get moderately confusing. So I have this method, I have this instant variable named fun, but I have another variable right here named fun. This is a local variable. This variable is instantiated inside the method change. And it says int fun equals 99. If I print this out right now, let's comment that out. And I have this second variable here, or sorry, I have this second method called print. And what it's going to do is it's going to print out the variable fun. What is the value of this fun variable right here? We didn't assign any value to it, so the value of that variable is 0. So when I use this method right here, the computer says, okay, I want to print out, he wants me to print out fun. What's the value of fun? It goes back to the variable that it can use. There are no instances of the word fun, of the variable fun, inside this method. You can see by the braces here, there's no variable called fun. So it goes to the instance variable up here, because remember, a local variable takes precedence over an instance variable. There isn't one in here. So when I run this and print, I'm going to get 0. Whoops. It'll get there. It'll get there. Okay. There we go. I get 0. Okay, so I run my program. Sorry, I should back up a little bit. These are all my methods. Method 1, method 2. This is my main method. Anything I want outputted has to be inside my main method. So I create an object called test that holds the same characteristics and behaviors as lesson 9A class. All right? It's called test, and then I say test.print. I want to run the method in the test class called print. It's right there. The computer says, okay, good. He wants me to run this. I'm going to run the value of fun. The value of fun is only defined for me right here. Therefore, the value of fun is 0. I'm going to print 0. Now, if I include a print statement in the change method, I have declared a local variable with the same name as this one, but it's local, and I've assigned a value of 99. And then I'm going to print that variable. The computer gets to this line of code, and it says, okay, there's a object created that holds all the same characteristics of this class, so it can call on either change or print. And this object is calling the change method. Inside the change method, I have a local variable called fun with a value of 99 and a print statement to print fun. Because local variables take precedence, it's going to print out 99 and it's not going to print out the value 0 of this fun up here. Okay, so when I run that, I now get an output of 99. Okay, that's the only thing I wanted you to understand about this section is that precedence that local variables hold over instance variables. If there is a variable declaration within your method, that is the one that's going to print out, because that can become confusing when you start using modifier methods to change the values of different integers or variables. Okay, output there, 0. That's what all of this explains, is what I just went through. Okay, math return methods. You can save this right here, because there is questions on the test that relate to it. So you can save this right here. All of these are the uses. Okay, floor rounds down, ceiling rounds up, seal rounds up. Okay, returns x, y to the power of y. All of these can be useful things that you can use as methods within your programs. If we were to bring in a keyboard and run this, I have it set up for us right here. Okay, so I'm going to use the scanner class, so I have to import that class, and then I have to create a variable with that. Sorry, I have to create an object from that class that's going to allow me to prompt the user to enter data. All right, so if I start with this one here, I'm going to create the keyboard. So I'm creating a keyboard object, and now I'm going to use to create the keyboard object. So first of all, I'm going to prompt the user and say, hey, enter a double. And then when the user enters the double, I'm going to assign whatever the user enters to the double variable num. All right? By saying keyboard.nextDouble. That initializes the keyboard object. Whatever the user enters as a double goes into the value of the variable num. And then I'm going to print the value of num, but I'm going to use the math method seal. So math.seal, and I'm going to put num inside the brackets. That gives me a round up of whatever the user put in here. So they put in a double, and I'm going to round up whatever they put in. Okay, so when I run my program, I get the prompt, enter a double, so I'm going to say 55.55. And enter. Now it prints out this statement. After it assigns a value to num, it prints num, but it's using this math method right here. And it's important to note the way the brackets work. Any method has to have the brackets open and closed following it so that you can have parameters set up. These brackets here are a part of this method. And then I need my print method brackets on the outside of those. So that's why there's two brackets at the end here. Okay? That one prints it, and then it says, okay, math.seal, that means I'm going to round up whatever that number is. And so I entered 55.55, but it's going to give me 56. Now be careful, this is not just rounding, like the print function that we used in the last lesson. This is rounding up regardless. So if I say, if I run that again, and the double the user enters is 55.00001, when I hit enter on that, it still rounds it up to 56. Because seal rounds up no matter what. As soon as it's over 55, it's going to give 56. And then vice versa when we use floor. Floor rounds down. If you had 55.99999999999, it's still going to give you 54 because it's going to round down. Or sorry, 55 because it's going to round down. Okay? Questions? All right. So I'm going on to the next one. Is random, and we did talk about random already, but I'm going to give you just another little look at how math.random works. So if I print out this line right here, system.out.print math.random, that's going to give me a number between 0 and 1. Okay, and it's a randomized number between 0 and 1. That's not very useful when it comes to randomizing a number. If you wanted to create a guessing game, or you wanted something, it's not very useful between 0 and 1. So rather than just use math.random, if we use math.random times 10 and we cast it as an integer, then it's going to drop that decimal place. All right, if we don't cast it as that, using this integer, even though we created this as num.2, I believe it'll give us an error. Let's see. Yeah, so it gives us an error because we've called num2 an integer. But this operation is going to create a double because it has a decimal place. So it's saying, hey, that doesn't work. This is an integer. If you want it to be an integer, you can't use this method because this method creates doubles. So I cast it and say, even though the answer is going to be a double, I want you to make it from a double into an integer, which just means it's going to drop whatever the decimal place is. Plus, we're going to times it by 10. So now that random number that kept being generated up here is going to be times by 10, and the decimal place is going to be dropped. And it's going to give us a whole number. Oh, it's going to do that if I print out number 2. Okay, so when I print out number 2, it gives us whatever that was. So this randomly generated number was 5.666528798832, or sorry, it was maybe 0.569235568. We times it by 10, that moves the decimal place to 5 point whatever, and we casted it as an integer, so it drops the decimal. And that gives us a new randomized number every time. Okay? All the way through. Questions? Okay, that's everything that happens in this page here. This one, we've already done this before. I have examples of it and how it works, but we've done this one before. If we create a user-defined return method, so we can say return methods have a return type specified before the method name. Okay, so the return type is right there. And then if we want this method to return 2 times whatever x is, I have an example of that right here. So inside my class, I have my method called public int twice. So the name of the method is twice. It's expecting an integer to be passed into it whenever it gets called. And when it gets called, it's going to return 2 times whatever number was passed in. And then down here in our main, we create a class, or sorry, we create an object, return 1 demo. So the name of the object is demo. And then we're going to print out a string that says first value returned, add demo, and then use the method twice with the value inserted of 0. So this one is going to insert 0 into this method, and it's going to return 2 times 0. Because we're printing this, it prints out that return number. 2 times 0 is going to be 0, so that's what we'll get as an output. The second one is going to be print the second value returned, demo.twice, 225 times 2, which is 450. And then this one is just a square root, so we're just using math square root. Instead of using the method that we have in here, we're going to use the math method square root of 25, and it should return 5. Okay, so the first value returned is 0 because 0 times 2 is 0. Second value returned 450 because 225 times 2 is 450. And we're using the math method of square root. Square root of 25 is 5. Okay, that's all that's in this one right here. We've done that already, so it should be relatively new. And just a quick review on the different methods we can use. So we have a constructor method here that's used to initialize the value of instance variables, modifier methods that can then take those instance variables and assign them a value when the method gets called, and accessor methods, which are going to print out all of that data into a usable output that the user can see. Okay, those are the methods that we've gone over right now. Any questions on constructors, methods, modifier methods, accessor methods?